So far we had seen these filters. Let me take this pen. So we had seen low pass filter, we had seen high pass filter, we had seen band pass filter, and we had also seen band stop filter. In each filters we had seen passive and active. We also solved some simple problems in each category: passive, active, passive, active. If you use only R and C components to design, then there is passive filters. And if you also use some kind of active elements, that is like transistors or operational amplifiers, then they are active filters. So please try to remember this filter design. You will get the lab experiment or lab assignment based on these filters. You need to design these filters in the circuit board or the kit you have already, and you have to analyze this, and you can see the frequency response. So you can apply different frequencies to the low pass filter and high pass filter, and you can see, observe at the output what frequency you are getting. So now I think we can go to the new topic. So far we have completed these filters, and if you have questions, just ask me. So filter responses are very straightforward also. It's very simple and easy to remember. Low pass filter is passing only low frequencies and blocking the rest. High pass filter is passing only high frequencies and stopping the rest. Band pass, this is the band stop, is passing low and high and stopping the mid range of frequencies. The band pass is the opposite. So this is the band stop, and the band pass means so it's just passing this band, blocking here and here, and passing only this one. And you should also remember the circuit, how to construct the circuit. The low pass filter is very simple, and high pass filter is also very simple. So in the low pass filter, we have the resistor in series and capacitor in parallel. We are getting the output across the capacitor in the low pass filter. The high pass filter is the opposite. Of course, we are using the operational amplifier to amplify this output and get some gain. So this is the low pass filter. The high pass filter is just changing the component positions. So resistor will come here and the capacitor will go here. Then it will become the high pass filter. So it's like this. So now the capacitor is here. Now we are getting the output across this resistor. So this is the high pass filter, and we are giving the output to the operational amplifier to get some gain. And also if you cascade more filters, for example, now I want to cascade more, then I have to do one more capacitor, and then I have to put one more resistor. So now what is this? This is the second order filter. So now I get the output here across this resistor. So now the roll off will be minus 40 dB per decade. And then I can also add here one more operational amplifier, plus minus, and I have output here, and then I give the negative feedback. So this is second order filter, and I can add one more stage here, and then it will be a third order filter, and so on. So this is also how to construct this high pass filter, and this is an active high pass filter. And the band pass filter is even much more simple, just cascading them together, and you are getting this band pass filter. So you have this capacitor and then the resistor. You get, of course, the output across this capacitor, and you are also adding one more stage, that is the low pass stage. Here is the first stage or first section, second section, and here you are adding resistor and capacitor, and you are getting the output across this capacitor. So now you are getting the band pass output. And band stop filter is the same. So you are adding this is the low pass filter. You have the resistor and capacitor getting the output across this capacitor, but we are using amplifier and we are getting the final output here or the output of this operational amplifier. The same here, you have another high pass filter getting the output across the resistor, but we are feeding this to this operational amplifier and amplify this or isolate from the other section, and we are getting the output from the operational amplifier and feeding them to this summing amplifier via input resistors, and you get the output like this. That is the band stop filter. It's rejecting a certain band and then passing the rest of the frequencies. So these filter designs are not very complicated. It's easy to remember, but try to remember the frequency response, how it works, and remember the formulas. Formulas also very easy. All the cutoff frequencies are just 1 divided by 2 pi RC, and the resonant frequency or FR is equal to 1 square root of FL times FH, and the bandwidth is equal to the difference between FH and FL, FH minus FL, and the quality factor. By dividing this FR and BW, you will get the quality factor. So filter is not very complicated.